Okay, thanks for coming out, everyone. Great to be back in South Carolina. I went to school in Spartanburg. Like Todd said, I live in Raleigh now, and just happy to be with you. The topic, you may have seen the why behind JavaScript frameworks and how to learn them. So it's kind of two parts. The first part, the why behind JavaScript frameworks, it's a little bit more theoretical, high level, and then how to learn them a little bit more tactical. So my hope is that there's something in there for everyone. And I'm a software engineer by day at a company called Praxent, which is in Austin, Texas. And it's a great company. Love it. And I'm on Twitter at PJ Elbaum if you want to follow me. I don't tweet that much, but I feel like, people in tech are supposed to say, like, I'm on Twitter. So I'm on Twitter. So the first part, the why behind JavaScript frameworks, like I said, a little bit more theoretical. So we've got this great meme from The Hangover. First, before I get into it, I want to kind of bring you all into the talk. So I'm curious if anyone has any kind of preconceived notions or ideas about what you think the main problem is that JavaScript frameworks solve. So I won't tell you if I think you say the thing I have in mind, but if you just want to call things out, any preconceived notions?
I have to rewrite a lot of the same code repeatedly in order to get the same thing that everybody, the plumbing for the same activities that the same people have to do every single project. And so the hope is that a framework is going to mean that somebody wrote it once and we can all just reuse somebody that did it a lot better than I did.
Okay, so reusability makes sense. We will touch on that in some way. Anybody else? Maintainability.
Once it gets fixed somewhere else, you can apply the fixes on your own side.
Right, so similar idea. So this idea of being able to reuse code, componentizing things, stuff like that. Okay, anybody else?
Package things so that non-blocking and I/O or the reactive pattern is more approachable.
Okay, patterns for sure, making it more approachable. Definitely, we're going to talk about that a little bit. Anybody else? Okay, those are all good. Yep.
Making it easier to add build tools to your project. Like if you want to use TypeScript or something, it gives you like all the build steps already laid out for you.
Okay, so tooling, basically enhanced developer experience. Okay, those are all important. I'm going to touch on those. Thank you guys. Okay, so in order to place frameworks in a context that I think makes sense in terms of talking about why they were created in the first place, I think we have to place them in a historical context. So Todd was talking about the dot-com boom. I wasn't doing development at that point, but I think it's important to talk about a little bit of the history of JavaScript. I won't belabor it too much, but just for a sense of how did things used to be, what were the problems that were around, and what do frameworks do to solve those problems. So briefly, in 1995, I'm sure many of you know, JavaScript was created by Brendan Eich at Netscape in 10 days because they were trying to make a proposal and they wanted a working demo for it. So 10 days, pretty quick, right? And so I think we're still dealing with the legacy of that to some extent today. JavaScript developers, for people that have been around a bit longer, for JavaScript, it wasn't considered a serious language for a long time. It was kind of considered a toy language. It has a ton of gotchas, things that don't quite work as you would expect. And so that kind of led to this idea that it wasn't to be taken seriously. And that was the case for a really long time. It came about in the time of browser wars, so IE, Netscape. I'm not quite old enough to really have a grasp on that, but something we still deal with, for example, in IE and some other browsers, is struggling with consistency and implementation, right? And so that had to do with CSS, also JavaScript. So Internet Explorer had a competing version of JavaScript called JScript for a while, and they had tried to reverse engineer it, and it wasn't quite right. And so things weren't super consistent across browsers. Same went for CSS. So you may have seen acid tests where you have a picture of a smiley face, and this is how it's supposed to look, and then you pull it up in IE, and it's just like a pixelated mess. So that was the case for a long time as well. JavaScript needed a standard. And so eventually it was determined that ECMA International was going to be the body that came up with the standard. So they met for the first time in November 96. And then ES1 came out in June 97. And so at that point we had standards and a way of doing a common implementation. On the note of browser wars, you may remember, I'm barely old enough to remember kind of this page best viewed in this browser or this browser, Netscape or IE. And so that kind of goes to the heart of why we needed a standard implementation for JavaScript and all the other parts of the web as well. So I would say JavaScript went through kind of a wandering in the wilderness period from about 1999 to 2009, or maybe a little bit earlier. So ES3 came out in 1999. ES4 was axed due to political reasons, so they couldn't decide on the features that they wanted to include in the language, and so it was completely skipped. And then ES5 came out in 2009, and so there was that kind of 10-year period where JavaScript itself wasn't advancing a whole lot. On the other hand, there were a lot of things that improved. So browsers in general got better. JavaScript met the W3C compliance for things like the DOM. Ajax came out in April 06. I think that's a really big deal. And jQuery in August 06. And libraries in general. So I was talking with a colleague about this, and he said, make sure to talk about libraries. And so he was telling me, this is a guy that's been building websites. He said, longer than JavaScript has been around. So it gives you some context. He said, when jQuery and libraries came out, that's really when they went from being websites to web apps. And you see kind of the result of that today. If you use an NPM module, that's a library, right? And so that really took it to another level. Chrome came along and kind of became the leading browser. Of course, in 2007, the iPhone came out, and then mobile web experiences became a really big deal. There was kind of a decline in native desktop apps. We were expecting this kind of feature-rich app experience from the browser. And then, like I said, ES5 came out in December 2009. Also, Node came out in 2009. And so now you're able to write JavaScript, not just in a web browser, but also on the server. And so I think that did a lot to aid in its credibility and make it be taken a little bit more seriously. And so then after that, the first frameworks came out. July 2010, Knockout, which I've never used, but that was kind of, in my research, the first framework I could find that came out. And then not too long after that, Angular and Backbone were released for the first time within just a few weeks of each other in October 2010. And so I think it's important to note that, Node comes out, ES5 comes out, and then less than a year later, you have the first frameworks. And so I think all of these things kind of converged and made it possible for us to have frameworks in the first place. And then, of course, after that, you had the first package managers, Bower from Twitter in 2012, and then NPM in 2014. And so that is kind of the historical convergence of how these things came about. But I think it's important to talk about what it was like to write JavaScript before frameworks and why they were necessary in the first place, right? So this is an example I took from an article that I'll cite in a few moments. It's a little bit small, but the basic idea is that you have an input field, you put an email address into it, you enter it, and then you have a list, and then you have a button that says delete, and you can remove them from the list. So about as simple as it gets in terms of a UI and functionality. This is the vanilla JavaScript code to write just adding an email address to the list. So I don't know how the resolution is on that, but you can see that's about 20 lines of code. It's doing a lot of different stuff. We are coming up with IDs. We're adding the ID as an attribute to DOM elements. We're creating DOM elements. We're injecting DOM elements. We're giving those items IDs so we can remove them from the list later. So there's a lot of stuff going on here. And it's not really that fun to look at. And there's a lot wrong with it. I would say we sort of have a problem here, right? There's a lot of issues with writing nothing but vanilla JavaScript that I think are important to talk about in terms of understanding the problem that frameworks solve, the main problem. So issues with writing nothing but vanilla JavaScript. It's hard to write. So you saw that previous example. You're having to just write a ton of code. And if there's a simpler, cleaner way to do it, I usually like to do it that way. So it's just not that fun in that regard. It's hard to read. So you have to do a ton of reasoning about what is actually going on in order to figure out the purpose of the code in the first place, right? And as a result, it is super fragile, like this warehouse. It's super hard to maintain. And keep in mind that this is about the simplest example you could come up with. Imagine how much harder it gets when you have a super feature-rich web application that has a ton of functionality, right, and a ton of interactivity. It gets exponentially harder to write and maintain and reason about if you're just doing it in vanilla JavaScript. And so that gets us to this article, which I wanted to mention. This is the deepest reason why modern JavaScript frameworks exist. It's on Medium by Alberto Jimeno. This is kind of the article that got me really thinking about this in a deeper way. And it's a lot of the reason for this talk. Those examples I took with that simple app and the code snippet I took from this article, so just wanted to give credit. But the reason that this article talks about was really revelatory for me, because previously I had kind of thought about frameworks and the reason for them in ways that weren't actually getting at the core issue. And so those were things like, the reason frameworks exist is so we can have components. And components are super nice. They're great. They make your code really reusable, much more readable. I would say something like, well, they make us faster at developing, or they make developing easier, or they make our code more reusable. So we kind of mentioned some of those things. Or they have large communities, so they bring us all together. We can learn from one another. All that stuff is great. But the number one reason that JavaScript frameworks exist, and the reason that all these other things serve, is that keeping the UI in sync with state is really hard with just vanilla JavaScript. That's it. All those other things, components, reusability, all the other things that come with frameworks, ease. The reason it's easier is because it makes keeping the UI in sync with the state easier. All these things kind of converge on this one goal, and they're in support of this one goal. So the whole reason that frameworks exist, and the thing that hadn't been solved before they came around, is keeping the UI in sync with state and sharing data across a whole app. So that's why they exist. At least that's what I've come across in my research, and that really resonated with me. So that was kind of mind-blowing for me, like this guy on the right. For me, it was super clarifying, because previously I had thought some of those things I just mentioned. Oh, we have them because it makes life easier. But why does it make life easier? It makes life easier because it makes maintaining the application state way more clear and easier to do and simpler, right? And so, like I said, all those other reasons, components, speed, ease, reusability, are in service of this one goal of maintaining your application state. And when you consider the history that I was talking about, I think it makes sense. So we had all these developments, better browsers, libraries, jQuery, stuff like that. Nothing up to that point had solved this issue. So I found a quote from one article that said, while jQuery was the most popular JavaScript library, it lacked facilities for handling data consistently across shared views. And so that is a problem that frameworks solve. And that's why they're so useful and why they're so great. And so I hope this is helpful. It was super clarifying for me when I first came across this concept, and the more I thought about it, it really began to resonate, and it's shaped a lot of my thinking and the way that I do development at this point. So before I talk about learning, I just wanted to talk a little bit about abstractions. So quick definition, this is from Types in Programming Languages. So the abstraction principle basically says that each significant piece of functionality should be implemented in just one place in the code. When similar functions are carried out by distinct pieces of code, it's generally beneficial to combine them. So this is basically the dry principle, right? So A practical example is just a function, right? So I can write a function body again and again and again every time I need it, or I can put it in a nice function and just call that function whenever I need it, and that's great. But the thing is, especially with frameworks, it's abstractions built on abstractions built on abstractions, and I think the more abstractions you have, the further you get from the problem that the abstractions are solving, and the harder it is to reason about what's actually going on. And so basically, the more abstractions there are, the harder it is to have as firm a grasp on what's actually going on. And so that, I would say, is not a risk, but just something to be aware of, because I think the helpfulness of abstractions is limited by how deeply you understand them. And when you really, really understand their implementation, it gives you more knowledge about when a particular abstraction is an appropriate solution for a given problem. And so I think without understanding this, keeping the UI in sync with data, it can kind of be lost on us a little bit, the true reason behind frameworks and kind of what they're appropriate for, right? And so the flip side of this is that, how deep do I really need to go? So I wouldn't say that everybody needs to understand the implementation of React's virtual DOM. That's the reconciliation mechanism. In order to be a good React developer, I do React on a daily basis, and I don't understand how the virtual DOM works, and that's okay. But I don't think it would hurt to know that, right? And so I think the more that you know about the actual implementation, the better. It definitely doesn't hurt, and it kind of gives you a wisdom as to when particular solutions are appropriate and when they're not. And so with that, I wanted to talk about learning JavaScript frameworks. So given that we've talked about the reason they exist, what are some actual tactical strategies for learning them? So I think it's important to frame your learning. So remembering the reason why they exist is really beneficial. So like I said, keeping the UI in sync with data, given that framing, and remembering how the tools aid in that goal is super helpful because, for a lot of reasons. So given that all the frameworks are solving this problem, I'll touch on this later, but they have more in common than they don't have in common. And so for me, at least, it could be a little scary to pick up a new framework, but when you understand that they're all trying to get at the same thing, even if it's in different ways, I think that just makes it a little bit less intimidating. It also helps you kind of focus and avoid the noise and avoid flame wars. So I particularly don't like to get into like, oh, this is the best framework, or oh, this is the best framework, because they're all solving this problem. And so there's not really any need for it when you grasp that, because it's really just not a stylistic thing, but really an implementation thing and kind of a philosophical thing. But they're all getting at this issue, right? And so I think understanding that, for me at least, has helped me kind of not get into the kind of this one's the best type of thing. There's a lot of ways to solve the same problem, but the three major frameworks have core commonalities, so I was kind of getting at that. But like I said, they have a lot more in common than they don't have in common, and at their core, they share a bunch of traits, which I'll get into, but I think this is just an important way to frame when you're starting out. And it also takes a lot of pressure off picking one over the other, because what you learn is transferable. So I'll get into that a little bit too. So commonalities, I mentioned they have a lot more in common than they don't have in common. So given that they all exist to solve this one problem of keeping the UI in sync with data, what do they all have? So they all have components. So I've used all three of the big ones. So not this big three, but Angular, React, and Vue, right? Though I like the Celtics big three. And so they all have components. So that is HTML templates and local data, and they're hooked together and they give you a way of displaying that data. They all have a reconciliation mechanism, which is super, super, super important. That's getting at that core issue. And that is a difference from web components. So I had a colleague, beloved colleague, I love the guy. He would talk a lot about like, man, I wish we could just do everything in web components. It would be so much easier. We wouldn't have to deal with node modules and all these updates and stuff, and we could just have it right there and it'd be great and it'd be so much simpler. But I disagree with that, because web components don't have a reconciliation mechanism. And so you're having to do that by hand. And so you're losing that benefit that frameworks give you. So I wouldn't say that web components are the same thing, and that is a core difference. So in React, this is Shadow DOM. It's called Shadow DOM in other frameworks, I think, as well. But that's really important. They have a way for components to interact. So in React, that's a unidirectional data flow, so it's all kind of going down. In Angular, you have this concept of emitters, so you can pass data up. But in every framework, there's a way for them to share data and talk to one another. And they're all written in JavaScript. So I have here, it's just JavaScript under the hood. For me, that is really important because it gets at fundamentals, which I'll talk about. But if you know JavaScript, then you can learn these frameworks. And whenever I'm intimidated, I usually just try and remind myself it's just JavaScript under the hood. And so the particular implementations may vary, but ultimately that's what they are, right? And so that helps me. I think it's important to understand the ecosystems no matter what you end up picking. And I'm not really trying to prescribe one over the other. That's not really my purpose tonight, but I will talk a little bit about the variances in the ecosystems. I think that's important to know before you get into it. So like I said, they all solve the same problem, but they do it in varying ways. So Angular is a little bit more fully featured framework. It's really common in the enterprise. So a common stack is like Angular front end, C#, .NET Core backend, or Java backend, stuff like that. For a few different reasons. Angular is more fully featured, like I said, so you get a router out of the box. You get a structure out of the box. So when you run ng-new in your command line, it kind of is prescribing for you what an Angular app should look like. And for a lot of people that are used to something a little bit more structured, that's great. You get TypeScript out of the box. And so basically you have everything you need for your development and you get it all out of the box. But the flip side is it's a little bit more heavy. The learning curve is a little bit steeper, I would say. On the other hand, you have Vue, which is incrementally adoptable. It's Vue's whole thing. So if you have an older app, you can use a CDN and just drop it in and use it for what you need. They have this concept of single file components, which I think is kind of cool. Though we have that in React as well, a little bit more with like style components and stuff. But their whole thing is you have everything you need, but you can just kind of use it as you need it and adopt incrementally, right? One difference between Vue and React is that Vue has all these add-on libraries like a router, state management, stuff like that, but they're maintained by the Vue core maintainers. And so there's a consistency there, whereas React, for example, React Router is not maintained by the core React team. It's done by React training. And so that is a difference. React, of course, backed by Facebook, it's used all over the web. I'd say it's the most popular framework at this point, though I think Vue has more stars on GitHub. Like I said, won't get into the flame wars, but my point with all this is that they vary in the approach, but still they have more in common than they don't have in common, right? And so I would say before you pick one, just do some research, know what you're getting into, and know why you're choosing one over the other. What are the distinctives? What are the things that are being offered to you? What are you maybe missing out on? And the transition between them is easier than you might think. So I'll talk a little bit about my own experience, but I've done React professionally. I've done Angular professionally. I've done a little bit of Vue, not professionally, but I've also done React with Redux. I've done React with GraphQL. And so among all these things, I'll get at a learning strategy later, but the transition I think is easier than you might think, though it is intimidating. Okay, so principles for learning a new framework, regardless of what you pick. Learn the fundamentals. So I mentioned they're all just JavaScript under the hood. I don't think JavaScript is going anywhere, at least not right now. Maybe WebAssembly overtakes it at some point or something like that, but I don't think it's going anywhere. Learn the fundamentals. There's a lot of great resources out there, and the fundamentals will always serve you, I would say. And I would advocate this approach first, so learning the fundamentals first before learning a framework, because it's hard to distinguish, if you do it the other way, what is JavaScript and what is React, for example. And so it's really easy to kind of mix them and confuse what one offers versus what the other offers, or what's a feature in one and not a feature in the other. I'd say seek out the best teachers. There's a lot of good resources. Like I said, some of my favorites, Wes Boss does JavaScript courses, Kent C. Dodds, another JavaScript guy, Egghead, which is a platform. I also like this guy who I didn't put on the slides named Dave Sedia, who also does just React training courses, but his style has really resonated with me of late. Third, build real stuff. This is super important, and I'll get at that a little bit in the next slide, but super, super, super important for really internalizing. And then fourth, I was kind of getting at this before, but learn the philosophy behind the framework and what is available to you in order to solve problems. So like I said, they're all dealing with the one main problem and then other similar problems. So global application state, for example, or you're using Redux or you're using Vuex, stuff like that. Just know what's available to you, but the philosophy is really important. So the philosophy between Angular and React, for example, is pretty different, and their approach. So that is really important before you start, I think. My experience, so I'm going to get at a little bit of kind of what my experience has been like in some more tactical stuff. So like I said, I've done React professionally, both with Redux and GraphQL, and also Angular. So I started out doing React, then I did Angular for a year and a half. Then I went to my current job where we mostly do React and Redux in a boilerplate. And then I've been on a GraphQL project for the past 2 months. And so it's really easy to build these things up to be like really scary, especially for me, it was Redux. I was like, oh man, I'm taking this job, I have to do Redux. And it seems so confusing. I'll get to kind of what the good patterns are for internalizing those things. But some things that have helped me, learning from courses. So that's a good starting point, but it's not a good ending point. Next best, learning from others. So if you compare with somebody, and then learning by doing is the best. And that's because it's really easy to, like I say in the third point, a video course is not knowing. And it's easy to just watch a video course and feel like, oh, I know this thing now. And then go to use it and be like, wait, hold on, I have to wait, how they do this? And so when you go out and build stuff on your own, that's why I say learning by doing is best. You really internalize whatever the framework or library or tool is, and it just makes it stick a lot better. And it took me a really, really long time to learn this, so I would watch a Redux course and be like, oh yeah, I know Redux, and then go to use it and be like, oh, okay, yeah, maybe I don't. And so building stuff on your own is the best way I know to internalize a lot of these concepts. All frameworks have a core set of patterns, so this is what I was getting at kind of with Redux. The thing where it really clicked with me is I had kind of made it this big scary thing. And at the end of the day, they have actions, you have reducers, you have the store, and that's pretty much it. And so I've noticed in my life in the past year or so that the Pareto principle comes up shockingly often, that otherwise known as the 80-20 rule. That basically says that 20% of the inputs are responsible for 80% of the outputs. I think that applies with a lot of this framework stuff. So there's a core set of patterns in every library or framework. So in React, that would be props and state. In Redux, like I said, actions, reducers, and the store. And by learning those core patterns, you are able to get up to productivity way faster. So for me, it's not about knowing every single possible detail. It's about knowing enough to be productive and get my job done most of the time. And I think learning those core patterns and trying to just distill what those are is the fastest way to do that, paired with building your own stuff, right? And so I wanted to belabor a little bit this building real stuff because that's kind of been a huge revelation to me in the past, I'd say 6 months or so, maybe 6 months to a year. And this had never really taken hold for me before because building stuff outside of work always felt like more work. And the way that I kind of approached it was, well, I need to build side projects because everyone says that's what you need to do. And I'm just doing this to put on a portfolio and prove that I'm employable. And I found that that is actually, for me at least, not great motivation. So I would maybe start and then stop and never pick projects back up, which I still kind of do, but really just had no motivation to push through any of the hard times or getting stuck. And something that really changed for me was Number one, having an idea for something I wanted to exist in the world and realizing that I had the skills to build it. And number two, solving a real problem. So these screenshots are examples of one of each. So the first one is an email from my wife. So that's an example of solving a real problem. So I noticed that she was, for her job, she was having to update her company's website. She works for a summer camp. And she was updating the wait list. And it was just like snippets of HTML. And she was having to like get a report from a database in a CSV, go down the CSV, and then like copy the values and paste them into these HTML snippets. And it would take her like 2 hours every other week. Being a programmer, I noticed like, hey, I could probably automate that. And so I wrote a Node script that took in the CSV and outputs the HTML. And it takes me 2 minutes. So she sends me the CSVs and I send her back the HTML. And so that's an email from her saying, this is still so life-changing. Thank you. And that's not to blow my own horn, but it's just to say that for people that don't know programming, knowing how to code is like magic. And when I realized that, it took me a really long time to realize that because it's like I do this every day, right? And so for me, there's not as much magic anymore, but realizing that I was able to use my skill to solve real problems in the world was super motivating. The other thing here is from a web app I've been building, working on the side, called Campmate, which is basically an online directory where you can search for and filter and all that summer camps. So they're both related to summer camps, just kind of by nature, I guess. End up noticing problems since my wife talks about it a lot. And that is an example of something I wanted to exist in the world. And I have loved working on this. And we'll do it outside of work and love talking about it and talking to people about it. And so that was another revelation for me. It's like, wow, I will push through the blockers and my code breaking and stuff not working because I want this thing to live out in the world and I want people to use it. And so if you can latch onto those things, I think that's really helpful. If you don't have a big idea, I would say there are still a lot of options. So you can replicate a well-known app. There's plenty of things out here, you know, like the Rails tutorials, like building a blog. But, you know, if you're full stack, you could like replicate Hacker News or Reddit, stuff like that. You can do a variation on a common idea. So one of my favorite people on the internet is called Harry Dry, and he runs this website called Marketing Examples. He got really well known for this Kanye West themed dating app, which is called Yeezy Dating. So there's a million dating apps out there, right? But he did a Kanye West themed one and got a ton of attention for it, and I think had a great time. So you can do a variation on a common idea. You can enhance a simple project. So I mentioned Wes Boss. He has a course called JavaScript 30 where you build 30 pretty small projects, one a day for a month. So that's why 30. And that's a great way of internalizing the fundamentals, back to the fundamentals point. But can you enhance a simple project? So can you add features? Can you figure out a way to like, okay, maybe I'll do this differently, or maybe I'll just add another feature or enhance it in some way. So those are all ways of building real stuff on your own. If you don't have kind of a big idea or a problem you want to solve, and that's totally okay. I would say start small. Just a script will do. Maybe not if you're trying to learn a framework, but for example, this script I built for my wife, that could be turned into a web app, right? And I actually have plans to just turn it into a web app so she can go ahead and upload and download the HTML without me having to like get the email and do stuff, right? So there's always ways of automating a little bit more. And so if you're solving a problem with some scripting, I think most things would probably make pretty good candidates for a web app. So if there's things around you that you notice that can be automated, maybe you build a little app that can do that stuff. And so I think regardless of what it is, just making stuff is a really, really great way to learn, regardless of which framework you pick. So that's really it. I also just wanted to have a bit of a shameless plug. I work for a company called Praxent, like I mentioned, which is in Austin, Texas. There's a bunch of us that work remotely kind of in Raleigh, and we're hiring this month. So we're hiring a software engineering manager, a QA automation engineer, and React engineer. So if any of those sound like you, just talk to me. I'll get you a referral link. And yeah, that's really it. I have resources here that I used to prepare for this talk, so I'll tweet the slides out or give them to Todd so you can get these. But that's really it. I'm open for questions, or I'll also be here if you want to talk.
Yeah, let's do, if we could, let's keep the cameras rolling.
Okay.
And we're going to do maybe 5 minutes of Q&A.
Sure.
And then we'll do maybe 5 minutes. By the way, you kept it right at 40 minutes.
Oh,
You're
perfect.
Very good. I think it was 40 minutes on nose.
Great.
We'll do 5 minutes of Q&A. I think there might be a few questions.
Sure.
If not, we'll move to Jim.
Okay.
Then we'll speak for about 10 minutes, and we'll try to get everybody out by about 8 o'clock. Does that sound fair? So if you have a question, fire away. And we'll do this for about 5 minutes. Questions? Bueller?
Sure.
On one of the slides you mentioned that you like following Ed. What was the other one that wasn't up there that you mentioned?
Oh yeah, I probably should have put that there, but it's a guy named Dave Sedia. So Dave, and then his last name is Ceddia. Really great. He's awesome. It's just like I think it's about finding who you resonate with. Is really important. So a lot of people like Wes, and he's great, but this guy Dave has really just resonated with me. Something about the way he explains things. So that's an important point, I think.
Be sure
Yeah.
to repeat the question.
Oh, sorry. So
They don't have a mind.
yes.
All you have a mind.
Great. So that was the person I mentioned that wasn't on the slides. So Dave Sedia. Anyone else?
What's your recommendation for handling like component sharing across frameworks?
Okay, so recommendation for sharing components across frameworks. You mean in the same app, or?
No, within like if you have different dev teams that pick different frameworks, can you share stuff between those frameworks?
So I think it'd be really tough. So it kind of depends too. So like, for example, a lot of node modules you can use in whatever you're doing. So Moment, for example, which we use for formatting dates, ultimately they compile down to just plain JavaScript, right? And so yes, to some extent, but I'd say it'd be tough like if you were like building out a React component and then trying to compile that down and then use that in Angular or something. I think it'd be complicated. I've never tried, but my recommendation would be to just to write a node module and publish that, so that way it's ultimately compiling down to JavaScript and you can use it wherever you want. And in fact, so I worked as a contractor for a really big company, and they basically had like their own internal node modules registry where they could create components, but they were all using Angular because it was enterprise, but they had their own internal set of Angular components that they used across the org. So that's kind of an option. Anyone else? Sure. Yeah, so philosophies between the various frameworks. So I touched on this a little bit, but I would say the philosophy behind Angular is like, I'm giving you everything you could possibly need right out of the box. So that's kind of what I was mentioning with like, you get a router, you get tests, you get TypeScript, which is just like nice for developer experience. You get all this stuff. You get a service layer. So that is kind of like what you get out of the box, and it also enforces a structure. So if you use the Angular command line tool to spin up a new project, it comes to you with a file structure that is like pretty standard, I would say. And so they kind of have like a de facto way of structuring the project, which for a lot of people can be confusing if you're coming from a background where everything is in its kind of folder and you're used to knowing where everything should live. React doesn't do that at all. So if you use Create React App, for example, which is the tool that you use to spin up a new React project, it will just like kind of give it to you, and it gives you like an app.js file, and that's it. So there's really like not that many. It doesn't enforce a folder structure, and it's like very loose. And I worked with a lot of Ruby on Rails developers for about 2 years, which is the opposite of React in that sense. So convention over configuration is what they say. So it has a standard structure that they enforce across every Rails project. And the Rails developers I worked with found it really kind of infuriating that it's like they didn't have a touch point for what a standard folder structure was. And And then also like data sharing. So Angular, you have two-way data binding. So you can, if you have like a parent component and a child component, they can share back and forth, but React has a unidirectional data flow, like I said, so it basically only goes down. So there's a lot of variances like that, where it's like some of it is kind of like a data flow methodology type of thing. Some of it is like, how should I structure this project in the files and folders? So that's kind of what I was getting at by philosophy. Does that kind of answer your question? Yeah.
I have a question.
Yeah.
Do you have any recommendations for dealing with, say for instance, I wrote a web application in Polymer 1 back when it was brand new. And now, we're on Polymer 3 and Polymer 1 is depreciated, but I want to add like some, newer features or move my code base away from the depreciated version of Polymer. Do you have any recommendations for something like that?
Yeah, so the question is, if you're on Polymer 1, you want to upgrade, any recommendations? So you're talking about like you want to migrate the whole thing and upgrade everything?
Pretty much.
Yeah, so major version upgrades are really tough in general. So I think, not to discourage you, but generally it just involves a lot of banging your head against the wall. So it's like you do the upgrade and then like everything breaks and you're just kind of like fixing things one by one. I mentioned I did Angular for about 2 years, and Angular has a major version release about every 6 months. That's just the way they've decided to do it. And even like, if not that much change, we'd still be like coming in on whatever day it was and just be like, okay, let's do the upgrade, and then like everything's broken. So it's just kind of like par for the course, which I hate to say, but that's maybe the downside of the way that the JavaScript ecosystem has evolved, is that like it's moving so fast, it's really hard to keep up to date in a lot of ways. And that, I think, is kind of the appeal of something like web components. Like I mentioned my colleague who's like, oh, we wouldn't have to deal with node modules. That's why that's really appealing, is because you have like greater control over what's happening, but you also miss out on a lot of the benefits. So I don't have any specific recommendations aside from like patience. I hope that helps. Yeah. Anyone else?
We, doing what we do, we always have our ear to the ground as far as what's coming next. You touched on React, you touched on Angular, but you also referenced WebAssembly. We're hearing WebAssembly more and more and more and more. And you said, well, WebAssembly might overtake React at some point. Who knows what the future holds? Do you want to maybe expand on your thoughts on WebAssembly? What makes it, what makes it attractive? Why are more people talking about it? And should we be paying more attention to it?
Yeah, so the question is, WebAssembly, why is it important? Why are people talking about it? Should we pay more attention to it? So I'll say I'm not an expert in it. I should probably do a little bit more reading, but basically the concept is that you have this language that compiles down to JavaScript. So it's a way of being able to write JavaScript without actually having to do it. And so I think that's right? And so basically the idea is that for browsers, JavaScript is the only programming language that runs in the browser, and you're kind of beholden to it, and that's been the case since 1995. And so this idea is that like maybe we can have languages that will run in the browser and kind of free us from the grasp of JavaScript. There's another implementation that I'm blanking on that I think is like an implementation of Clojure that compiles to JavaScript, but it's not a completely new idea, but WebAssembly has kind of been gaining some traction, and I saw a talk on it. It's, I think, popular for like people that have maybe work in the enterprise or need their code to be super performant, but I say WebAssembly, stuff like that is kind of like moving away from native, so to speak, and JavaScript running in the browser is definitely worth paying attention to, because it just seems like eventually that might become at least an option. And I know that I think some companies are actually using WebAssembly now. And so it's just kind of a trend that's, I think, still pretty early, but worth paying attention to, because things are always changing, right? And so just good to be aware of what might be coming on the pipeline is kind of the way I'm viewing it right now.
There's a lot of WebAssembly and Google stuff, like when you start running images.google.com and all that,
Right.
manipulation tools. A lot of that's WebAssembly.
There you go.
Peter, I didn't
Yeah.
mean to put you on the spot.
No, it's okay.
It's just that we are really hearing a lot about WebAssembly. There seems to be a lot of excitement about it, and a
Yeah.
lot of wondering if it will overtake React, or a lot of people wondering should I be paying more attention to this? Should I be learning more about WebAssembly?
Right.
And so we're featuring more talks on it. We're seeing more talks come through on it.
Right.
More people submitting talks on it.
Mhm.
So we're in a kind of a unique position in that we can, I don't know, we collect data that a lot of other people don't collect. So we see what people are wanting to speak on, what they're wanting to learn more about, and then what they're asking about as well, what they're asking that we feature at conferences. And I can tell you that WebAssembly is at the top of the list.
Right. Yeah. Like I said, not an expert. I hope everything I said was right, but look into it if it piques your interest at all.
Well, we won't hold you to anything because
Yeah.
again, I sort of totally blindsided
That's
you by
okay.
the question, and I certainly apologize for that.
No.
Okay. And again, that was like my own personal. I pulled that one because I've been thinking about that one for a long time.
Sure.
As well. So okay. So with all that said, I got 7:40. Why don't we go
Great.
ahead and transition over to Jim? Jim, if you could speak maybe 10 minutes or so, and that'll give us 5 minutes to wrap up, and we'll try to get everybody out by 8 o'clock. I know it's a work night. A lot of you have families. A lot of you have other things to do, and work responsibilities and obligations.